Imagine a storm so massive it could swallow Earth whole. A tempest that's raged for over 350 years without showing signs of stopping. This is Jupiter's Great Red Spot, a swirling, crimson vortex that has baffled scientists and ignited imaginations for centuries. But what if I told you this colossal storm, once thought invincible, is mysteriously shrinking? What secrets lie within this deadly storm? Could this be a sign of a much larger change happening on the King of Planets? In today's video, we're diving deep into the heart of the solar system's most infamous storm to uncover what's really happening inside Jupiter's Great Red Spot. If you're fascinated by the wonders of space, make sure to like this video and subscribe to our channel. Stick around, because what you're about to learn might just change how you see our cosmic neighborhood forever. Imagine peering through a telescope and witnessing a storm so colossal that it could easily envelop our entire planet not once, but 11 times over. This is Jupiter's Great Red Spot, a swirling, crimson vortex that has fascinated and perplexed scientists for centuries. To grasp its magnitude, picture Earth's most powerful hurricanes, and then multiply their size and ferocity by an astronomical factor. This storm isn't just large. It's the largest in the entire solar system, spanning a width of about 16,350 kilometers, 10,159 miles. But what's even more astonishing is its age. The Great Red Spot has been raging for over 350 years, making it one of the most enduring weather phenomena ever recorded. This is no ordinary storm. It's a persistent, planetary giant that has survived through centuries of space exploration and astronomical discoveries. But the story of the Great Red Spot doesn't end with its size or longevity. In recent decades, something unexpected has happened. The storm is shrinking. Imagine watching a grand, ancient oak tree slowly wither before your eyes, its once mighty branches growing frail. That's the kind of transformation we're seeing with Jupiter's iconic storm. Once sprawling across 40,000 kilometers, the Great Red Spot has been gradually contracting, now measuring just over half its original size. This change has left scientists at NASA and other space agencies puzzled, sparking new questions about what could be causing this legendary storm to diminish. Is it a natural progression, or could there be something more mysterious at play in Jupiter's volatile atmosphere? As researchers continue to monitor this shrinking storm, it opens up a fascinating dialogue about the forces that shape Jupiter's weather systems. Could this be a sign of changes happening deep within the gas giant itself? Or perhaps it's an indication of the storm's eventual demise. Whatever the case, the Great Red Spot remains a symbol of the mysteries that still linger in planetary science. And while it may be shrinking, its significance in space exploration and our understanding of gas giants is anything but diminishing. This curious phenomenon draws us deeper into the heart of Jupiter's atmosphere, where the science behind this massive storm is waiting to be unraveled. When we talk about Jupiter's Great Red Spot, we're diving into a storm unlike anything we experience on Earth. Jupiter itself is a gas giant with no solid surface, and it's this unique composition that plays a key role in the storm's ferocity. The planet's atmosphere is primarily made up of hydrogen and helium, swirling in violent, continuous motion. This lack of a solid ground means there's nothing to slow down the storm's rotation, allowing it to persist for centuries. Combine that with Jupiter's rapid rotation, spinning once every 10 hours, and you have a perfect recipe for an eternal tempest. The storm's characteristic red hue, often debated among planetary scientists, is thought to result from complex chemical reactions between the elements in Jupiter's atmosphere, possibly involving phosphorus or sulfur compounds, though this remains one of the space mysteries we're still trying to solve. But what keeps this massive storm going, you might wonder? Unlike Earth's storms, which lose energy as they interact with landmasses, the Great Red Spot has no such barriers. Some theories suggest that the storm is powered by heat from Jupiter's interior, with warm gases rising from deep within the planet, feeding the storm's energy. Others propose that it could be fueled by Jupiter's immense magnetic field, which might be interacting with the storm in ways we don't yet fully understand. This idea ties into the broader field of planetary science, where researchers are constantly exploring how magnetic fields influence weather patterns on other planets. As NASA continues to send missions to study Jupiter up close, we're slowly peeling back the layers of this giant gas planet, uncovering the mechanisms that drive its extreme weather, including the Great Red Spot's seemingly endless power. The science behind the Great Red Spot isn't just a tale of a massive storm. It's a window into the inner workings of Jupiter itself. Every discovery about this storm gives us more insight into the nature of gas giants, helping us understand not just Jupiter, but also other similar planets scattered across the universe. What might seem like just another storm is, in reality, a cosmic laboratory teaching us about atmospheric dynamics, planetary magnetic fields, and the very formation of storms on a scale we can scarcely imagine. The more we learn about Jupiter's Great Red Spot, the more we realize just how complex and interconnected the forces at play in our solar system truly are. One of the most captivating aspects of Jupiter's Great Red Spot is its astonishing longevity. Earth's storms, even the most powerful hurricanes, last mere weeks before they dissipate, exhausted of their energy. Yet here we have a storm that has persisted for centuries, defying the typical life cycle of any storm we know. This raises a perplexing question. Why has the Great Red Spot endured for so long? Some of the latest research suggests that deep atmospheric currents within Jupiter may be at work, continuously feeding the storm with energy. These currents could act like an underground river, sustaining the storm in a way that no earthly hurricane could ever hope to match. It's as if Jupiter itself is nurturing this storm, keeping it alive far beyond what we would expect from a weather system. Another intriguing theory revolves around Jupiter's powerful magnetic field. Unlike Earth, Jupiter's magnetic field is vast and incredibly strong, and it could be playing a crucial role in the storm's persistence. There's speculation that this magnetic field might interact with the Great Red Spot, helping to stabilize it and prevent it from dissipating as quickly as storms on Earth do. This interaction could also explain why the storm has managed to remain so consistent in its location and intensity over the centuries. However, as the storm gradually shrinks, it hints that even Jupiter's mighty forces may eventually lose their grip, leading to new questions about the future of the Great Red Spot and what this might mean for Jupiter's overall atmospheric dynamics. As we delve deeper into these theories, the Great Red Spot continues to mystify scientists, offering a tantalizing glimpse into the complexities of planetary weather systems. Could the storm's gradual shrinking signal a significant shift in Jupiter's atmosphere? Or is it simply a natural evolution of a storm that has already defied so many expectations? The answers to these questions could reshape our understanding of not only Jupiter, but also the behavior of gas giants throughout the cosmos, leaving us with even more space mysteries to ponder. The Great Red Spot isn't just a fascinating phenomenon on its own. It's also a key to understanding the broader dynamics of Jupiter and other gas giants in our solar system. This storm acts like a natural laboratory, allowing scientists to observe how such massive weather systems behave in the absence of a solid surface. By studying the Great Red Spot, we can glean insights into the atmospheric processes that may be at work on similar planets, not just in our own solar system, but in distant star systems as well. For example, learning how this storm interacts with Jupiter's magnetic field could help us better understand the weather patterns on exoplanets that are thousands of light years away. The lessons we learn here could be pivotal in the field of space exploration, as they might inform the design of future missions to study other gas giants and even the search for extraterrestrial life. But the implications don't stop with Jupiter itself. If the Great Red Spot continues to shrink, it could herald a significant shift in our understanding of how stable these giant storms really are. Could this mean that Jupiter's atmosphere is undergoing a transformation? And if so, what might that mean for the planet's future, and by extension, the stability of other gas giants? These questions lead to broader considerations about the very nature of planetary evolution and the forces that shape the cosmos. As we continue to monitor the Great Red Spot, we're not just watching a storm. We're witnessing a chapter in the ongoing story of our solar system. A story that could have far-reaching implications for our understanding of space mysteries and astronomical discoveries. And as we look to the future, the fate of the Great Red Spot will no doubt influence how we approach the study of planetary science and extreme weather on a cosmic scale. As we've explored the mysteries of Jupiter's Great Red Spot, it's clear that this storm is much more than just a weather phenomenon. It's a window into the forces that shape not just Jupiter, but the entire solar system. Now, imagine what we could learn if we applied this knowledge to understand the dynamics of our own planet, or even those distant worlds that might harbor life. Have you ever thought about how these cosmic insights could change the way we live on Earth? What if we could harness the power of understanding extreme weather to better predict and prepare for storms here at home? If this video sparked your curiosity, don't stop here. Hit that like button, share this video with friends who love space mysteries, and make sure to subscribe to our channel for more deep dives into the wonders of the universe. And don't forget to turn on notifications so you never miss an update. Speaking of planetary extremes, did you catch our last video on how Venus turned into the solar system's inferno? If you're fascinated by how a planet can go from being potentially habitable to a scorching wasteland, you won't want to miss it. Click the link to watch and continue your journey through the most mind-blowing phenomena our solar system has to offer.